Okay, this video is going to be an example problem for chapter 4, and it's kind of a takeoff on perhaps a real-world problem as well. At least I'm going to focus on some of that, and those real-world problems will also translate to test problems sometimes as well. So I'm going to describe the problem kind of in real-world terms. Let's say you're a chemistry technician, lab tech, and the chemist you work for runs in, and as usual, doesn't spend much time with you and says, well, I shouldn't say that, but you know, it says, quick, I need a 0.25 molar solution of chromic ions, chromium III ions, and I need about a liter of it. Here's some. You think he says chromic oxide because he's in a hurry as usual. Chromic oxide, I need it's 0.25 molar solution of chromic ions. Thanks a lot, and he runs out the door. All right, so again, what you think he said is you want 1 liter, a one liter solution made up of 0.25 molarity chromium III ions. Okay. Now again, he didn't say anything about what the anion should be. Although again, he gave you this, and so you can kind of figure it out. So at first you're thinking, all right, he gave me chromium oxide, which chromic oxide, which is chromium in the +3 state, and so you work out the empirical formula. You know the empirical formula would be Cr2O3, again because it takes 2 chromics and 3 of the oxides to balance out like this. Okay, now there's 2 questions that come to mind. First of all, is that what he gave me? Because that's very important. I'm gonna have to weigh out some amount of a solid. And use the stoichiometry and use the molar mass to figure that out, which is, we've covered some of these problems already, but I'm kind of highlighting some interesting stuff here, which is, I'm not even sure what he gave me. And second of all, what he gave me, is it even soluble in water? Will it dissolve in water? A very important question, because he gave me something that when I put it in water, it doesn't dissolve, then I can't make the solution. All right. Anyway, you look at it closely, and it's like, it's not chromic oxide, it's chromic oxalate, or actually it says Chromium III Oxalate. Okay, well, that's not a formula for Chromium III Oxalate. What is? Well, this is where chemical naming comes into play, but I'm going to skip to the answer, which is oxalate is a carbon-oxygen polyatomic anion. And it's kind of analogous to carbonate. I'm going to draw carbonate, and then I'm going to draw oxalate to kind of show you that they're sort of analogous. So carbonate, which I think I've shown already, the empirical formula for carbonate is CO3 2-, and oxalate is similar, except it has another carbon. Oxalate looks like this. Okay, and again. This is also a 2- charge, and we'll get into that in subsequent chapters to how you would know that. But the oxalate anion is analogous, but it has an extra carbon and an extra oxygen as well. All right. So what we have then, what the guy gave us was chromium and some number of oxalates. Remember, 2 carbons, 4 oxygens. And we know this is -2 and this is +3. And so we work it out just like we did before to know that the empirical formula would look like this. 2 chromics, that means +6. 3 oxalates, that means -6. And therefore, that's the empirical formula for our solid. Okay. All right, good. And we sure hope this is soluble in water. We'll test it real quick. We put a little bit in it. It's like, yeah, sure enough, it dissolves great. So the guy's not crazy. If it didn't dissolve, you'd have to go back and say, I'm going to have to dissolve this in acid or something. You'd have to go back for some more instructions. So we'll assume that this solid is soluble in water. Now let's figure out. And again, the usual thinking going into this is we have a certain number of a desired amount of molarity of the cation in this case. And we're given this solid. So first of all, we need to figure out the molar masses of this, and then from there we'll figure out how many grams of this we need to add to solution so that we end up with a 0.25 molar solution of chromium 3. One key thing before I get into the math, though, is to note that the solid that we're given here actually has 2 moles of chromium for every mole of the solid. Okay, that's important, and this is where a lot of times people go wrong in their calculations, is that they sort of blindly think, oh well, we'll figure out how many moles of this thing we need, and they forget the fact that the moles of the solid does not equal necessarily to the moles of the desired cation. That'll show up in the math here, but I just want to point that out. All right, so let's get the molar mass of chromic oxalate here. So chromium's atomic number is 52. I'll write down just the atoms in question here. I'm going to just show 2 significant digits here on the carbon and oxygen. All right, so 2 chromiums, that's going to be 104, twice that. And each oxalate will have 2 carbons and 4 oxygens. That'll be 88. And so 3 of them is 3 times 88, 264. And so when you add up chromium, the 2 chromiums and the 3 oxalates, you end up with a molar mass of 368. Okay, this is the molar mass of chromium. By the way, I'll show you a little shorthand here. A lot of times oxalate is abbreviated as OX. It's just a shorthand abbreviation for oxalate. Okay, so the molar mass of chromic oxalate is 368. All right. So now let's go back to our equation. We want 1 liter of solution, and we want 0.25 moles of chromium per liter. Okay, that's what our request was that. Let me get rid of the math now here. Okay, and this is now one of the key terms here, is that there are 2 moles of chromium 3 plus for every 1 mole of Cr2OX3. Okay, every mole of the solid is actually 2 moles of the chromium ion. Okay. And then last, so you can kind of think about how the units are going to cancel. The liters will cancel here. That's good. The moles of chromium will cancel with the moles of chromium here. What we're left with so far is moles of the solid. Okay. And then we're going to one last time multiply by 368 grams per mole of the solid. And so, again, just very important when you do these calculations, make sure your units cancel properly. The liters will cancel, the moles cancel, the moles of chromium solid will cancel here. I didn't show the solid name. And what we're going to end up with is the amount of grams of the solid that we need to add to solution to make a liter of the solution. When you multiply this all out, it comes out to be 46, I believe. Let me do the math again. So that's going to be 0.25 divided by 2 times 368. Yep. And that will equal to 46 grams of Cr2 with 3 oxalates. This solid, 46 grams of this solid to add to solution, make 1 liter of solution with the desired concentration of chromic ions. Okay, that's it for this one.